So welcome to Team 3379 from Durham, North Carolina School of Science and Math. Welcome to the Moody's Mega Math Challenge, and your first question is, what is your name?
Good morning, my name is Alan Jang.
I'm Pranay Oragunta.
Anshul Subramanya.
I'm Margaret Tian.
I'm Chris Yuan.
Okay, Team 3379, you may begin.
Good morning, everyone. My name is Chris, and my team is here today to present our solution to Moody's Mega Math Challenge. So obesity in the United States is a growing epidemic. A recent study done by the Center for Disease Control indicated that 2 out of every 3 American adults are either overweight or obese. And the childhood obesity epidemic is growing as well. The heat map you see here shows childhood obesity rates across the country. The states in dark blue represent those with the highest proportion of overweight or obese children. This is for 2009, and in just 2 short years, the number of states in the dark blue has grown dramatically. The federal government has started several initiatives to try and curb childhood obesity across the country, one of which is the Healthy Hunger Free Kids Act of 2010, which implemented the My Plate standards for school lunches across the country. However, implementation of this act revealed conflict between the 3 main stakeholders: the federal government that wants healthy lunches for all of its students, the school districts that are most concerned with saving money, and the students that want tasty yet filling meals. And so in this presentation, we'd like to reconcile these 3 stakeholders by determining student caloric intake requirements, determining a national student satisfaction rating, and creating a balanced, tasty weekly meal plan in order to distribute in schools.
So in our first model, we look at creating an equation to calculate how many calories a student should be eating at lunch. And we did this with the following assumptions: that children eat 3 meals every day, and that each meal contains around 1/3 of their daily caloric intake. And then we used BMI definitions for overweight and obese. So we began by looking at what equations already existed, and we found several, 2 of which being the Harris-Benedict and ones created by the Institute of Medicine. So we chose to look more in depth at those created by the Institute of Medicine because they give very concrete values for how much you should be eating rather than a range. And so you can see here that this is the general format for the equation, and this depends on 5 different factors: your gender, your age, your weight, your height, and your physical activity level. And below is a table of constants for different age groups. However, we wanted to see what we could do to really improve upon these equations, and we decided to go about this in 2 different ways. First, we wanted to just improve the constants, give more accurate results for caloric intake. And secondly, we wanted to include additional parameters that we thought would also affect how much you should be eating at lunch.
So in order to determine a better model to figure out how many calories a student should eat every day, we actually looked at the Institute of Medicine's original paper, which it contained their original data set. It had 525 individuals with the following attributes collected: age, height, weight, body mass index, or BMI, physical activity level, or PAL, and each student's daily caloric intake requirement, or EER. So our objective here was to be able to find a function whose input is a student with a certain number of attributes and whose output is the student's daily caloric intake requirement. We see that the Institute of Medicine actually did this with this weighted linear combination, and their weighted linear combination had 3 terms, which were composed of the attributes age, height, weight, and physical activity level. We hypothesized that if we included more terms into this linear combination, we'd actually be able to come up with an equation that would better fit the original data set. To do this, we have to find the proper weights, theta 0 through theta n, that would do that. So in order to find these values for these weights, we used a machine learning technique called the gradient descent method on a least squares criterion. Using this, we're able to find the optimal values for theta 0 through theta n. Obviously, this is a pretty technical slide, so I'd be more than happy to answer any questions you have about this during the Q&A section. So running our gradient descent algorithms, we found these to be the optimal weights for both males and females. And looking at the table, we see the relationship between our terms and the original attributes. So we see that the terms x1 through x5 are the original 5 attributes collected by the Institute of Medicine. x6 through x10 are the squares of those attributes. And x11 and x12 are the physical activity level times the height and the physical activity level times the weight. And we included these 2 additional terms because we thought they might have some biological significance because they were included in the Institute of Medicine's equations as well. So next we wanted to be able to evaluate our equations versus the ones created by the Institute of Medicine, and we used the least squares criterion again. So what we found was that the squared difference, the sum of the squared differences between our predicted values for the total caloric intake requirements versus the actual ones found in the dataset was 2 orders of magnitude lower than if you had used the Institute of Medicine's equations to predict the caloric intake, which means that our equations are able to much better fit the dataset. Furthermore, we were able to find through additional research that the 5 original parameters or attributes found by the Institute of Medicine are not necessarily the only ones that affect how many calories you should consume in a day. Another study we found showed that whether or not you got enough sleep and whether or not you had breakfast that morning would also affect it. So we incorporated this into our equation, and what we said was that if you got enough sleep in the day, so for a teenager 8 hours or more, you could decrease your caloric intake by 5%, and if you did not get breakfast, you would increase your daily caloric intake by 17%. So as a summary, what we did in this model was we were able to find an equation that better fits the original data set found by the Institute of Medicine and include these 2 new additional parameters in order to calculate the number of calories a student should eat in an entire day. After that, we can divide this value by 3 to determine how many calories they should eat for lunch, which is a number that we're going to be using in our subsequent models.
Through Model 2, we should find the percent satisfaction of high schoolers throughout the entire United States with standard school lunches. Before we go about doing this, we made some standard assumptions. These are in place to fill in missing gaps in data. The key point to take away from these is that a standard school lunch provides approximately 850 calories. This serves as a basis of comparison to determine if the high school student is satisfied or not with their lunch. So, first we develop a sample set of 20 million high school students. Each of these individuals has different values for the parameters described in Model 1. These values are obtained from permutations of all of the distributions obtained from a CDC study conducted. Now, the point of this is to produce every possible student with every possible combination of values. Here, in the table below, we have an individual with these specific values, specifically with the weight of 90 kilograms. We then iterate throughout the weight column to produce a certain set of individuals, and then we change the height of the individual to 180 centimeters, and then proceed throughout the weight column again. This continues and iterates throughout every column. Note that all of these columns are the distributions obtained from the CDC study. For example, the CDC study showed that 80% of individuals consumed breakfast. This means that 16 million students of the 20 million students ran in our model will have eaten breakfast, and that will be taken into account. So, after we obtain all of these individuals with their different values, we then use the equations described in Model 1 to determine their caloric requirement for lunch. Then, we determine if that is less than 850 calories, they're then satisfied with their school lunch. So, we find that 60% of high schoolers throughout the entire United States are satisfied with their school lunch. We then want to geographically analyze this data and see if there are any disparities between different regions. So, we divide the US into 4 regions: the West, Midwest, Southeast, and Northeast. We found that the Southeast and Northeast exhibited much lower values for satisfaction than that of the entire United States. We then wanted to observe why. So we decided to delve back into the CDC data and see if there are any disparities between region by region data. We found that the Northeast exhibited much higher activity levels than that of the other regions, and that the Southeast had much higher incidence levels of obesity and overweightness, just generally having a higher average weight. These factors result in a higher caloric requirement, therefore decreasing the satisfaction rating.
We wanted to see if the socioeconomic status of these different states had an effect on the percentage of individuals in that state that were overweight or obese. So what we did was we calculated the average, we used the average household income from each state and divided it by a relative cost of living in that state, which was standardized against North Carolina, to create this income over cost of living metric, which was a measure of socioeconomic status. We then averaged this metric over each of the 4 regions, You can see that on the table to your right. And you can see that the Southeast has a lower income over cost of living ratio than the other three regions. And this shows that there may be some correlation between socioeconomic status and the percentage of individuals in that region that are overweight and obese, and then directly from that, the percentage of students that are satisfied with school lunches. Further studies need to be done in order to calculate the actual impact that this has and the exact correlation. So in summary, for Model 2, we created a national satisfaction metric that allows us to determine that around 40% of students were actually not satisfied with their current school lunches. And in the next model, we look to improve that with a weekly meal plan.
The goal of our third and final model was to create a tasty, nutritionally balanced, and within-budget meal plan that satisfies the needs of the students, the school district, and the federal government. To do this, we made the following assumptions. And of particular importance is an equal number of boys and girls in a school and school district. This comes in play when we see if we can meet the budget requirement, and that'll be explained shortly. The method for this section was to choose a number of representative foods, as shown in the list on the right, find their individual price per ounce, shown in the table on the left, average these values together to find a unit price per ounce for each food group, shown in bold, and conduct some simple calculations to see if we can meet the preset, caloric, and budget requirements. Looking at budget first, you can see we have the average price per ounce for each food group on the top of each table, multiplied by 5/3 the daily recommended serving size as suggested by MyPlate. We multiply by 5/3 because MyPlate suggests ounces in a daily dose, and 5/3 turns that daily recommended value into just the number of ounces in a week's worth of school lunches. When we do this calculation for both male and female aged 14 to 18, we find the cost per male student per week arrives at about $6.73, and the cost for a female student per week is about $5.22. Now, even though the male price per week does exceed the $6 budget, note that if we average the cost per week of the male and female student together, we do arrive at just below the $6 criteria. This means that if our previous assumption of an equal number of male and female in a school is correct, then the school will be able to satisfactorily feed all of its students and remain within its own budget. We then want to see if we can meet the caloric requirements of the students as well. We did a very similar calculation as before, but this time we found the average calories per ounce of each food group. Again, we multiplied by 5/3 the daily recommended serving size as suggested by MyPlate, and we found, and this table shows the calculations for a male aged 17 to 18. So when we do this calculation, we find that the number of calories provided to this male in a week's worth of school lunches is about 4,001, and this is almost exactly on par with what our own model suggests. We found that a male in this demographic will require about 4,050 calories in a week's worth of school lunches. Therefore, we've been able to come up with a model that meets both the budget requirement of the schools as well as the caloric and nutritional requirements of the students. In addition, since we don't specify any specific meals, we give far more liberty to the school in deciding their own meal plan, and we believe this attributes to the success of our model.
So now we want to look at what we would do differently if we had an extra dollar each week to feed the students. And since our $6 meal budget already met the government standards for nutritionally balanced, we decided we would take this extra dollar and really look at improving taste. And so we did this by, whoops, sorry guys. We did this by, it's not here. It's okay, I'll still talk about it. We did this by looking at an Iowa study done in their public school systems that asked their kids what they would like to see in their school lunches. And the top two responses we saw were that they would like to see more fruit and fewer processed meats. So we decided we would take this extra dollar and really improve those areas. And here you can see a table of a concrete idea of what we would suggest a high school of around 750 students to purchase for their kids at lunch. And you can see we've broken it down based on food group, and this meets our budget. It's nutritionally balanced, and it's also very tasty. So now we want to analyze our three models that we've created. First, we look at strengths and weaknesses. The strengths are listed here, but I really want to highlight two of them. First is that our meal plan is very flexible. Since we defined it based on representative food groups, school districts have the ability to choose specific foods within that group based on what's available at that time of the year or in their specific region. And most importantly, our meal plan satisfies the needs of all three of our stakeholders. It is nutritionally balanced as defined by the federal government. It is within the school district's budget, and it's also tasty enough that students would want to eat it. Looking at our weaknesses, one weakness is that we define nutritionally balanced as having the correct amounts of food groups. However, nutrition depends a lot on what vitamins and minerals you're taking in, so we would like to include this in further meal plans.
Next, we wanted to analyze the sensitivity of our model, or how much the output would change if any of the data given to us were wrong. And so this is for the national satisfaction equation that was in Model 2. And this is a national equation, so it uses the national averages for each of the 7 parameters given to us. And just intuitively, we can see that if the parameters given to us for any school district or even any state were incorrect, it would change the national average by very little, and therefore the output of this equation would change little. However, we did want to look at what would happen if the data given to us for the entire nation were incorrect. And you can see here that just changing one of the multipliers, physical activity, by a small amount, the satisfaction percentage does change quite a bit. So it's important when actually collecting this data in the real world. It's important to spend more money on making sure that the national values are accurate. So finally, in the future, we'd like to accommodate special diets such as vegetarian and celiac disease. We want to consider the body fat percentage as an additional parameter in our caloric needs equation. We want to thoroughly explore the effects of socioeconomic status, develop some kind of solid correlation and see what that is. And finally, refine our definition of nutritionally balanced in order to incorporate vitamins and minerals as well as just calories. So thank you for your time. Do you have any questions?
Okay, with your second degree equation that you decided to use instead of just the linear equation, you added 2 of the cross product terms.
Right.
Were there any of the other cross product terms viewed as significant? I guess you didn't think so. I was just wondering why those 2 particular cross product terms as opposed to others.
Right. So we added those 2 terms in particular because they were actually included in the original Institute of Medicine model. So the original Institute of Medicine model was actually a degree 2 polynomial.
It was.
And we thought that those 2 might have some sort of biological significance, so we put them in and we minimized it with those 2.
Did you happen to check to see how much, maybe you did answer this with estimating your, doing your prediction, but did you compare how much of the variation that was accounted for by going from the linear model to the
Right. So, I mean, the main way that we compared the effectiveness of our equation versus the Institute of Medicine was actually looking at the least squares difference between our predicted values in the original data set and the Institute of Medicine's predicted values in the original data set. And we found that our predicted values, like the sum of the square differences, was a lot lower for ours. In fact, 2 orders of magnitude lower.
Okay, thank you.
In the second part of your model, you assumed that the attributes were uniformly distributed, that the student populations it was a uniform distribution. Are there any of those variables that you think maybe perhaps, given a 14-hour time frame, that's an appropriate assumption, but are there any of those attributes that you think maybe don't really have a uniform distribution?
So, for example, you have your growth charts, standard growth charts for each individual, right? So there's data as to how tall an individual may be at, say, the 10th percentile, 50th percentile, and 90th percentile. Now, we assumed a uniform distribution in that we divided up the 100 percentiles into, say, 20 groups, and in each of those 20 groups, the height is the same. However, if we were to make a more developed and accurate model, we would have an actual growth chart curve as to describe the height per percentile growth. And so that would have a little bit of effect on our model, but since we have 20 million sample individuals, this will have a minor effect, but will still improve the accuracy.
Well, I also have a question on Model 2. And in particular, in this case, I really appreciate how you walked us through the looping structure of your model. I thought that was really helpful in order to see like how things were accounted for and how all these frequencies were accounted for, right? So that was really cool. The question I have, though, is like your main result there was you found like in the Northeast and the Southeast, there are these differences in activity levels and obesity, right? And you sort of drew to the same, similar conclusion that, well, they need more to be satisfied. My question is, though, is that, especially with regard to the Southeast, is that going to be consistent with the spirit, I guess, of the Healthy Hunger-Free Kids Act, right? That you're going to feed the obese people more food, and how can you address that in your menu plan?
So I think one thing is it's still important to meet the students' caloric intake. However, to really encompass the spirit of this act, there definitely should be other parameters. So eating healthier foods, meeting those nutritional requirements, while still providing them enough calories to get through the day. Just because our equation does take into account how much you weigh, all your different factors and attributes, and just calculate how much you need to just get through the day. So in terms of foods and making things healthier, we would want to really improve on that. But maybe the amount of calories that you should be getting, we should still be satisfying the needs of the students.
Right. So for example, weight is one of the terms in the calculation for how many calories you should get in a day. So obviously, if you weigh more, you should actually get more calories in the day, like simply to, I guess, like sustain your current weight level. So I guess that was the idea there. If we want to have everyone sustain their like how many calories they need in the day. So it's like total energy expenditure. That's how much we're planning on feeding them.
Okay, thank you.
Actually, I have a follow-up question to that. You look regionally at the country in terms of socioeconomic factors, etc., obesity. Did you also think about dietary differences between the different regions of the country, and also food availability, the different food availability?
So for that, we actually weren't able to look at the different foods that were offered in each region. Perhaps that's a good point, though. So perhaps in the future, when we look at trying to quantify the effect of socioeconomic status, we can look at standardizing the different foods that people eat in different regions and their nutritional content to try and isolate the effect of socioeconomic status. Does that answer the question that you asked?
Yeah, thank you.
Thank you.
I've got a question. You had the Southeast, including Michigan. How did that happen?
So if someone wants to go back, I think the colors may be a little off in that some of the states we didn't have sufficient data.
Oh wait, this is wrong way.
So,
Yeah.
oh, did we? The southeast. I think we basically just wanted to really divide it into manageable portions. So we had like the west of the country, the Midwest, and then kind of just like section the country into 4 sections. So of course, if we want to refine our model, we would really look at like the behaviors of different states and group them that way rather than just purely geographical.
Well, just a question. What do Virginia, Ohio, Minnesota, Iowa,
Those
Nebraska,
states,
and the West Coast, what region are they in?
those states we did not have sufficient data on to really input into our
okay.
model.
Sure.
So they are left blank.
Okay, I have another question. You wrote in your paper, all food will be prepared and students will be able to choose for themselves how much they would like to consume. Okay. Now, won't this affect the number of calories that the students will be getting for lunch?
I think, sorry, I think one of the basic assumptions that we made was that the students would be able to choose how much would be appropriate for them. So I know at least at our high school, it's there's food that you can choose, and you kind of choose how much you want to be eating, and then you pay based on that. And I think that we are assuming here that students would kind of have an idea of what they should be taking in, and then be able to choose appropriately based on that.
Yeah, I mean, this also takes into account like the disparity in cost for the males and females, and we're thinking that males would naturally just choose more foods than females, and that will be able to average out the costs like we suggested.
I like the picture you had of the table you had of things that would be bought, the kind of purchases that would be made. But you had like, I don't know.
This one?
Keep going.
Keep going. Keep going.
Yeah, yeah. What? Oh, I'm sorry. It is suggested weekly portions. I missed that. Thank you.
You still have time for the last one?
40 pounds, 1,000 pounds of oranges. Oh, wow. Yeah, we do. Sure. Far away.
One other question, and
real quick.
you maybe addressed this. You said something about sleep and ethnicity and trying to account for those things. Did you actually put those into your function h of x, or did you just?
No, because I mean the idea of h of x is you want to find an equation that best fits the original data set. and we didn't have all this data from the Institute of Medicine's paper of whether or not they got sleep or whether or not they got breakfast.
Okay.
So we had to kind of put those ad hoc, like after the other analysis.
Okay, so then this would just be a way of adjusting.
Right, adjusting the one that we got.
Now, in metabolism calculations, metabolism during sleep and sitting in class is of regard the same. Can we conclude that you guys are sleeping in class?
I think that wraps it. Thank you. Who knew?